Right, on this next page, I'm going to work through 17 and 19. 17 is with synthetic division. So remember, this only works when your divisor is linear, so it's to the first degree. If it's to the second or third degree, you by default need to do long division. So the way I'm going to set this up is I'm given a known factor for this polynomial. Or actually, sorry, I misspoke. In this situation, it's not a known factor. I'm just being told to divide by x minus 4. So we're going to start by setting up, we want to divide by the 0 or root of that factor. So I'm going to start with x equals positive 4. I'm going to change the sign. When you're already given a root, like if you look at number 19, it says the root is x equals 3. In this case, you don't change the sign for synthetic division. It's already been changed. You only do that when you're starting with the factored form. So x equals 4. Take the coefficients from your polynomial, 3, 5, negative 3, 2. If I was missing any x terms, I would put a 0 as a placeholder. But I'm not missing. I have x cubed, x squared, x to the 1, x to the none. And we bring the first coefficient down. Whatever number that we put here gets multiplied by that 3, brought here, that's 12, and then I'm just going to add up and down. And then I'm going to do it again. This 4 now times 17, which is 68, goes here. Going to add these, 63. Now 4 times 63 goes here, that's 260. I add 262. Whatever I get here is my remainder. And these are the coefficients of my quotient, or my answer. And I'm going to add the x's back in 1 degree less than what I started with. So it's going to be 3x squared plus 17x plus 63 plus my remainder over my divisor of x minus 4. I'll let you work this problem and check it with the PDF in your Google Classroom. Notice that there are missing terms here. I'll just help you get this one set up. X plus 3, you're going to start with negative 3 for your divisor part right here. For your coefficients, you're missing x squared, so you're going to put a 0. You have 5 for x, and you're missing your constants. You're going to put a 0 there also. Let's look at number 19. It says find the remaining roots of the polynomial. So in this problem, we do know that what we're given is a root. Up here, we were just given something to divide by. By the way, we know that this one isn't a factor of this because our remainder is not 0. So even the 0 of this factor, which is x equals 4, is not actually a root of the equation, because if it was a root, our remainder would be 0. But here we do know it's a root. So if our math is good, we should get 0 after doing synthetic division. So I have x equals 3. I don't have to change the sign because it's already in the correct form. I'm not missing any x terms. It's x cubed, x squared, x to the 1, x to the none. So I'm going to set up my coefficients. I'm going to do my synthetic division. I bring down the 2. 3 times 2 is 6. That goes here. Add. 3 times 1 is 3. That goes here. Add. And 3 times negative 3, 0. So I got my 0 remainder. So it's asking me to find the remaining roots. We get roots from factors. So we're going to have to factor this expression. I'm going to add my x's back in 1 degree less than I started with. So 2x squared plus 1x minus 1. I'm going to set up my swing method. What multiplies to AC and adds to B. So AC is 2 times negative 1. B is positive 1. So that's going to be 2 and negative 1. I have an A value that's non-1. So divide by the a. So my factors from here are x plus 1 and x minus 1 half. And okay, so I have a few things to say here. It's not asking me to write my answer in factored form. If it did, I would have to swing this denominator up here and write 2x minus 1 as a factor. But it's just asking me for my roots. So I can already tell that here. This factor gives me a root of -1. This factor gives me a root of 1/2, and then I'm already given the root of 3. So there are my 3 answers. Okay, this problem is set up kind of the same, but the main difference is that the given root is an imaginary number. So at this stage, it doesn't make sense to set up synthetic division the same way we did here. Because imagine for a second if we did that. And we bring our 1 down and multiply by this and write it here, it's going to give me 2i. Well, I can't add these two things together, and then it's just going to get, the math is just going to get uglier and uglier and uglier as we go on. So we need a different approach here for this problem. Our goal is still the same. We are being asked to find the remaining roots when given a root. So here's how we're going to begin. First, remember that if 2i is a known root, then -2i, its conjugate, is also a root. We talked about how we talked about our complex conjugate theorem. These are complex numbers. Conjugates are the positive and the negative versions, and they occur in pairs. So you can't have one without the other. So at least we know a second root, and we know we need 4 roots altogether because the degree is 4. That was our fundamental theorem of algebra. Whatever the degree is how many roots you have. So we have 2. We need to find 2 more. So here's how we began this the other day. We started out by saying, all right, I have these 2 roots, and I can write them in their factors, x minus 2i, x plus 2i. So I know that they're factors and they're multiplied to a portion of my polynomial. When we multiply these 2 things, this happens to be a difference of 2 squares, the i's end up dropping out. So follow my math here. I'm going to FOIL or double distribute. So distribute this x here and here, gives me x squared plus 2ix. And then I'm going to take the -2i and distribute it here. So -2ix, and then times the positive 2i. This is going to give me a -4i squared. So the 2ix's cancel. The x squared comes down. And -4i squared, remember we talked about that I squared is equal to -1. So I really have -4 times -1, which is +4. So this is a factor of my polynomial. And since it's a known factor, I can divide it into this one, get my remaining factors, and solve them for the roots. And the way I'm going to take this polynomial and divide it by this factor that I just found is using long division. So that's my second step. I'm going to take x squared plus 4 and divide it into my polynomial. And I actually, oh wait, actually, let me just say actually a few more times. X squared plus 4 is missing the x term, so I'm going to put a 0 there as a placeholder. And I'm not missing any x terms here. So I want you to pause your video and do your long division, and then come back to the video. I'm actually going to pause and do mine as well. All right, so you'll see I have a remainder of 0, which means my math was probably good. because we already knew that x squared plus 4 was a factor. So now I have this, x squared minus 2x minus 3. So I've got x squared plus 4 is a factor, and x squared minus 2x minus 3 is a factor. If I multiplied these two things together, I would get this polynomial. So now I have this trinomial, and I'm going to try and factor that, because remember, our goal was to get all the roots. So I am going to see what multiplies to AC and adds to B. It's negative 3 and 1. So that gives me factors of x minus 3, x plus 1. I had x squared plus 4 as a factor. Now, I already knew the roots from this one were positive and negative 2i. And then this one gives me a root of positive 3, and this one gives me a root of negative 1. So there are my 4 roots. All right, on this back section, we're actually only going to do the P's over Q's. We're not going to finish out these complete problems. It's more repetitive work, and there's not exactly problems like this on your test, so it's good enough to just talk about the P's and Q's. So we want to start by determining all possible roots. That's where we find the, let me do this one because it's got more factors. This is your P and Q. You're going to find all the factors of P, which in this case are 1, 2, and 4, and all the factors of Q, which is just 1, and make all the fractions you can using each P value as a numerator and all the Q values as denominators. So in this problem, it would just be 1, 2, and 4. Let me kind of show you a better one. Let's say that Q value here was, well, hold on one second. Let me check here something. Actually, that's good enough for your test. We did 1 over 1, 2 over 1, 4 over 1, and we got these potential zeros. And then you can see the rest of the problems in your PDF in your Google Classroom. We use the test bank we use synthetic division to test out the zeros. You'll notice if I didn't get 0 as a remainder, then I put a cross here. It was not a root. Once I found one that was, I knew that was a root, and I tried factoring. You don't have problems this complicated on the test, but they are good practice problems, so they are there for you as a reference. But we need to get to this last one. My video has 2 minutes left before it cuts me off. 23. Write standard form that has real numbers for coefficients and has these zeros. So remember, if you have 2i, you also have negative 2i. So I'm going to write factors for these. X minus 2i, x plus 2i, and then this 3 gives me a factor of x minus 3. So you want to FOIL these. Cancel, cancel. Remember, I squared is negative 1 times negative 4 becomes positive 4. And then times your x minus 3, you're going to FOIL. And then you're done. No terms combined. You can put an A here as a placeholder. That is your standard form equation with a degree of 3 and these zeros.